When driving a ground rod at the meter location, you do have to bring a grounding conductor from the service panel to both sides of the water main. The grounding electrode conductor must be a copper conductor installed according to NEC section 250.118. This conductor should have a rating of not less than 8 American wire gauge copper unless it is part of a cable assembly identified for direct burial that is rated not less than 8 American wire gauge copper. According to NEC section 250.50 A3, the grounding electrode shall be connected to the system grounding electrode conductor at the service entrance by the main bonding jumper. NEC section 250.24b further clarifies these requirements. To elaborate on the requirements for grounding electrodes and grounding electrode conductors, it's essential to delve into the specifics outlined in the National Electrical Code, or NEC. The NEC provides a comprehensive framework for ensuring electrical safety, and proper grounding is a cornerstone of this framework. Grounding serves several critical functions, including minimizing the risk of electrical shock, providing a path for fault current to flow back to the source, and stabilizing voltage levels within the electrical system. When installing a ground rod at the meter location, it's not sufficient to simply drive the rod into the ground and assume that it will provide adequate grounding. The ground rod must be properly connected to the electrical system using a grounding electrode conductor. As stated previously, this conductor must be made of copper and installed according to NEC section 250.118. The size of the grounding electrode conductor is determined by the size of the service entrance conductors. For most residential services, an 8 American wire gauge copper conductor is sufficient. However, larger services may require a larger conductor size. It is crucial to consult the NEC to determine the appropriate conductor size for the specific application. In addition to connecting the ground rod to the service entrance, it's also necessary to bond the water main to the grounding system. This is typically accomplished by connecting a grounding electrode conductor from the service panel to both sides of the water main. The purpose of bonding the water main is to ensure that it is at the same electrical potential as the grounding system. This helps to prevent electrical shock hazards in the event of a fault. According to NEC section 250.50 A3, the grounding electrode must be connected to the system grounding electrode conductor at the service entrance by the main bonding jumper. The main bonding jumper is a conductor that connects the grounded conductor, typically the neutral, to the equipment grounding conductor at the service entrance. This connection provides a low impedance path for fault current to flow back to the source, which helps to trip the circuit breaker off fuse and clear the fault. NEC section 250.24b provides additional details on the requirements for grounding electrode conductors. This section specifies the acceptable methods for connecting the grounding electrode conductor to the grounding electrode and the service entrance. It also includes requirements for the size and installation of the grounding electrode conductor. To ensure compliance with the NEC, it's essential to carefully review all applicable sections of the code and to follow the manufacturer's instructions for all grounding equipment. It's also recommended to consult with a qualified electrician to ensure that the grounding system is properly installed and meets all applicable requirements. Improper grounding can create serious electrical hazards, so it's important to take the necessary precautions to ensure electrical safety. Let's further examine specific scenarios and considerations when implementing grounding systems, drawing upon the NEC for guidance. Consider a situation where the water main is made of non-conductive material such as PVC. In this case, the water main cannot be used as a grounding electrode. Instead, an alternative grounding electrode, such as a ground rod or a concrete encased electrode, must be used. The NEC provides detailed requirements for the installation of these alternative grounding electrodes. Another important consideration is the location of the grounding electrode. The grounding electrode should be located as close as possible to the service entrance. This minimizes the length of the grounding electrode conductor and reduces the impedance of the grounding path. The NEC specifies the maximum allowable length for the grounding electrode conductor. In addition to ground rods and water mains, other types of grounding electrodes are permitted by the NEC, including concrete encased electrodes, ground rings, and other approved electrodes. The choice of grounding electrode will depend on the specific site conditions and the requirements of the local electrical code. When installing a grounding system, it's important to ensure that all connections are clean and tight. Loose or corroded connections can increase the impedance of the grounding path and reduce the effectiveness of the grounding system. The NEC specifies the acceptable methods for making grounding connections. It's also important to protect the grounding electrode conductor from physical damage. The grounding electrode conductor should be installed in a conduit or otherwise protected from damage. The NEC specifies the requirements for protecting grounding electrode conductors. Regular inspection and maintenance of the grounding system are essential to ensure its continued effectiveness. The grounding system should be inspected periodically for signs of damage or corrosion. Any damaged or corroded component should be replaced immediately. The NEC recommends a schedule for inspecting and maintaining grounding systems. Furthermore, the NEC addresses the use of supplemental grounding electrodes. In some cases, a single grounding electrode may not be sufficient to provide adequate grounding. In these situations, supplemental grounding electrodes may be required. The NEC specifies the requirements for installing supplemental grounding electrodes. When using supplemental grounding electrodes, it's important to ensure that they are properly bonded together. This ensures that all grounding electrodes are at the same electrical potential. The NEC specifies the acceptable methods for bonding supplemental grounding electrodes. The NEC also addresses the grounding of specific types of equipment. For example, the NEC includes specific requirements for grounding swimming pools, spas, and hot tubs. These requirements are designed to protect people from electrical shock hazards. It's essential to consult the NEC when grounding any type of specialized equipment. In summary, proper grounding is essential for electrical safety. The NEC provides a comprehensive framework for ensuring that grounding systems are properly installed and maintained. It's important to carefully review all applicable sections of the NEC and to follow the manufacturer's instructions for all grounding equipment. Consulting with a qualified electrician is also highly recommended to ensure that the grounding system is properly installed and meets all applicable requirements. The grounding electrode conductor serves as a crucial link between the grounding electrode and the electrical system, providing a low impedance path for fault current to flow back to the source. The size of this conductor is determined based on the size of the service entrance conductors, as specified in the NEC. For residential services, an 8 American wire gauge copper conductor is typically adequate, but larger services necessitate a larger conductor size to handle potentially higher fault currents. The NEC provides specific tables and guidelines for determining the appropriate conductor size based on the service entrance conductor size. When connecting the grounding electrode conductor to the ground rod, it's essential to use a listed and approved connector. These connectors are designed to provide a secure and reliable connection that will withstand the rigors of the environment. The connection should be made in a manner that minimizes the risk of corrosion or loosening over time. The NEC specifies the acceptable types of connectors for grounding applications. In addition to connecting the ground rod to the service entrance, it's also necessary to bond the water main to the grounding system. This is accomplished by connecting a grounding electrode conductor from the service panel to both sides of the water main, typically within 5 feet of the point where the water service enters the building. The purpose of bonding the water main is to ensure that it is at the same electrical potential as the grounding system, thereby minimizing the risk of electrical shock hazards in the event of a fault. The grounding electrode conductor used to bond the water main must also meet the requirements of the NEC, including the minimum size and material specifications. In situations where the water main is made of non-conductive material, such as PVC, it cannot be used as a grounding electrode. In such cases, an alternative grounding electrode, such as a ground rod or a concrete encased electrode, must be used. The NEC provides detailed requirements for the installation of these alternative grounding electrodes, including the minimum size and depth of the electrodes. The location of the grounding electrode is another important consideration. The grounding electrode should be located as close as possible to the service entrance to minimize the length of the grounding electrode conductor and reduce the impedance of the grounding path. The NEC specifies the maximum allowable length for the grounding electrode conductor, as well as the acceptable methods for routing the conductor. Regular inspection and maintenance of the grounding system are essential to ensure its continued effectiveness. The grounding system should be inspected periodically for signs of damage or corrosion, and any damaged or corroded component should be replaced immediately. The NEC recommends a schedule for inspecting and maintaining grounding systems.